Bismillahirrahmanirrahim. Now we are covering the examination questions of chapter 2, which covers from 2.5, 2.1 to 2.6. Here have some worked examples, and finally the exercise 2.7 that belongs to exam exercises. So we have solved it all in 2.7. So we see 2.7 here. So for 2.7 we have the set of values of k for which the line does not intersect the curve is. So we have to find the value of k for which this line does not intersect the curve. So we put the value of y here. This line equation will equate with this quadratic equation. So we will compare this and we'll have a single quadratic equation, and from where we will get the discriminant which is less than 0. If discriminant is less than 0, we will get this marks, 5 marks. This was asked in IGCSE June 2014. So if we can solve it, we can solve it in our O Level exam. So problem number 1, for we have to find the value of k, and we have a line equation this, and we have a curve this, and this line should not intersect with this curve at any time. So these two equates, and we have formed a single quadratic equation, and from this single quadratic equation we have x square, x, and a constant term. This is a, this is b, and this is c. So b square minus 4ac, we place this b value 4, and then a, and then c, and less than 0. For non-intersecting condition, this is the condition that has been. This is the whole concept on which this question has been asked. So we have not done anything special. We just equate these equations or place value of line in place of y and formulate it like this, and then find out this discriminant condition less than 0, from where we will find the value of k. So we just simplify it, and we have obtained this kind of equation. Here we have to factorize it, and then we have obtained this. So there are two possibilities: x is greater than 0 or x minus 4 is 0, because the condition is this. So we have this equation, k square minus 7x. The parabolic shape would be like this, because this is positive. So shape would be like this, parabolic minimum value. So for this we have this condition. So between 3 and 4 the value would be like. So this is important. So this is the same question that we have solved in 2.6, question number I think 9 or 8 or 9. So this is the same question. This is a similar kind of question. We have solved it here. So this is, you can get 5 marks. Just simple. Equate discriminant less than 0, find the value of k. Here you have this, and from where we have these two possibilities, and this is so simple. Now question number 2. Find the set of values of x for which this condition satisfies. So this condition satisfies, we have to solve it. So this is write down, and this condition has to satisfy. So these inequality problems. So, so this is the problem. So we have opened it. We can shift it on the right, and this. So these we have to satisfy this. So this is the conditions: x is less than 0 and x plus 1 is greater than 0. So this is again a parabolic shape. X is greater than 0, or x is less than 0 or x is greater than minus 0. So we have a curve that is between 2 points. So here we have -1 and has 0. For this we have this. This is so simple. Now question number 3. Express this in the form of this, where p, q and r are constant to be found. We have to shape this polynomial into this form. We will get 3 marks. So simple. We have done it earlier in 2.2 or 2.1. This is this. So we have to formulate this, and by equating it, this p is equal to 2pq is equal to -1. Here we place the value of p here, and q 154. P and q is placed here. PQR square 6, and we obtained this. So this r is equal to this one. P, q and r is obtained, and we place this in place of p, q and r. We have obtained this. So this part 1 is completed. 3a. And now from 3a we have the similar questions. State the least value of this and the value of x at which this occurs. So we have the minimum value of this. So minimum value, because this is positive, so it will have a curve like this, like this. So we can find out the minimum value by, in this shape, this q and r would give you a minimum value. So this is we have already solved it. So this is minimum value 1/4 and 5/7/8. Okay, so this is h and k. This is h and k. We have already solved it. So at this value of x we have minimum value. Minimum value occur at x is equal to 1/4. So this is the value where minimum value occurs. Exercise 3, problem number 3. Now move on to problem number 4. Find the set of values of which this curve lies below the x-axis. X-axis means, below the x-axis means y is 0. Y is 0. Below the x-axis, y is equal to 0 condition. We have to place that y is equal below the x-axis. Y is less than 0. Okay, we have this condition. The possibilities of k is this or this or this or this or this. Here we have this, so we can set it like this. So for these conditions we have this discriminant is this, and from there we have k values is half and minus 5 by 2. So both conditions, this will be below 0. So for k value, any condition could be possible, any curve, the shape of the curve, and that value that is below this for these conditions. So this is simple. Question number 4. Question number 5. Find the set of values of x for which this condition satisfies. This is again the inequality problem. Question number 5. We will solve it like we did earlier. Question number 5. So we will make shift it here and solve it. This is for 6 minus 6, and so this is the condition. This shape is parabolic. This is positive, means minimum value, where we have minus 6 to plus 3. This is the condition. So this is less than, so we will have this condition. This is simple. Question number 5. Question number 6. Find the value of k for which this line is tangent to the curve. Find the value of k for which this line is tangent to the curve. Tangent to the curve means discriminant is 0. Find the value of k for which this line intersects with this curve at one point. That is, discriminant is 0. Question number 0. This we have these two equations. Discriminant is 0 for which this value of k is obtained, minus 18 and minus 2. This is the solution. So we have equate this, and then from this single quadratic form equation, and from this discriminant applies equals to 0 for tangent condition, and from where we have value of k obtained as two different values possibilities. Question number 7. It is given that fx is equal to this. Find the value of a and b for which fx is equal to this. So we have to formulate this shape and value of a and b with respect to these numerical values, and then write down, and hence write down the coordinate of stationary point on the curve. Stationary points are, we know that these are the stationary points. So we will solve it. 7. A, this is compared with this one. And on comparison, we have done it earlier, so you can solve it. This a minus b square is equal to 4, but this minus 2b is equals to 8. This is minus 1 is same. So from this we have b value, and by substituting this we have a value. Replacing this a and b value at respective position, we have this stationary point of the curve is 420. 420 is the stationary, and the curve is a maximum. So this is, because this is negative, so the curve has this shape. So for the same problem, we have b value, we have this curve. This is 20. This is shape. We have to find the shape of the curve at x is equal to 4. This will give you a maximum value 20. For y, for x is equal to 0, this is y is equal to 0, this value. For x, y is equal to 0, we have 4 plus under root 2 minus plus minus 2. This two values will be this. So this is the draw. And now question number 8. Given the straight line, this is tangent to the curve y is equal to x square plus 9x plus k. Express k in terms of c. Express k in terms of c. So we have to solve this simultaneously, and then tangent condition means discriminant is equals to 0. So this is these two equations. So from this we have this conditions, a single quadratic equation, and from this we will, for tangent condition, we will apply this discriminant is equal to 0, and there we have this, and this k is in terms of c. This was the requirement. So question number 8, and now we will proceed to question number 9. Find the value of the k for which the line this and the curve this in two distinct points, means the discriminant is greater than 0. We solve this simultaneously and find the value of k by the condition that discriminant is greater than 0. We will get 6 marks for this. So this is two equations, so we equate it and we have formed a single quadratic equation, and from this we apply a discriminant greater than 0 for two distinct points. Because of these two distinct points we have this, and from here we have this equations, and so on. On simplification we have these two values. K is less than 10, sorry, this is less than 10. Because this is condition, because of these conditions, the curve is like this. So k is between -6 and +10. So this is less than. This is wrong. This is less than. This is greater than. So k is between -6 to +10. So we'll write like this: -6 and then k and then +10. So 10. Question number 10. The curve given by this is where a is constant, and given this equation can also be written as this. So we have to write this equation to this form, for which we get 2 marks, and the minimum value can easily be seen for this. So this 3 and b gives you a minimum value. If b is the minimum value, so question number 10. This is question number 10. We have to find 2x is equal to y 2x b3, and by equating we have a is equal to 12 and b plus 18 is equal to 14. So we have obtained this: a is equal to 12 and b is equal to -4, and y minimum is this value. This is y minimum. At x is equal to 3, the y will be minimum. So this is my minimum value. So this is very easy. It was equals to b, as I said earlier. This is b. So we have obtained this. So problem number 11. Find the value of m for which this line cut the curve this in two distinct points. This line and this has to solve simultaneously a single quadratic equation, and for which we will find a discriminant greater than 0. So we have these two equations, solved it, form a single quadratic equation by the combination of these two, line and curve. We have this form, and from discriminant is greater than 0 for two distinct points. So we have this condition, and here we have m is greater than 2 and m is less than 14. So again, this is again a wrong. This is less than 14. Less than 14. 2 to 14. It will give 2 to 14. Okay. Now problem number 12. On the copy of the grid on the right, sketch the graph this for y is equal to this. So we can see this curve x is equal to -2, means here we have a point and here we have -3. This is the point. So we will have a shape like this. For these conditions, so we have 2 and -3, so we will have this shape. We'll have shape, but for modulus value, this will be reversed on a positive side. In these conditions, we have to solve this. By this value, we have these two values. Coefficient is positive, coordinate is minimum point, and but this minimum value, so we have plotted it like this, and for this we have obtained, reverse this negative part because of the modulus, and we'll obtain some solutions. For two solutions, this line intersect at 2 points, but at this point we have three solutions, one solution, second solution, and third solution. And for the other points we have 4 solutions, so we can understand it by the graphical method. The C point with this k is positive. From graph k is greater than 6 by 1 by 4 will have only 2 solutions for this value. If k value is greater than 6 by 1 by 4, then there will be only 2 solutions above this curve. So this curve will be like this. So only this part and this part will intersect with this lines. So question number 13. Find the value of k for which the curve this pass through the point this. So we have to, curve has to pass through this point. So we put the value here and passes through the point. So it will satisfy this equation. We'll put the value here which will satisfy the conditions, satisfy it. So 13th. This curve passes through the point, so the value of x and y will be placed here. This curve will satisfy these lines, these points. So As a result, we will get the value of k. This is this, and meets the x-axis at one point only. If we have to find that the curve meets at only one point, means discriminant is 0. If discriminant is 0, then the value of this will be 1 over 9/8. So part 14, find the range of value of k for which this equation has two real distinct roots. When discriminant is greater than 0. So we find this from this equation, value of k for which this is, has a discriminant has greater than 0. So we solve this for two distinct roots. This discriminant is greater than 0. We have find out the value k is less than 2. For k is less than 2, this will give our two distinct roots. So question number 15. Find the set of values of x for which this is less than 0. Find the set values of x for which 4x square plus 19x minus 5 is less than or equals to 0. Express this in the form this. So we will express this in this form first, and then using part answer of this part A, find out the greatest value of this. So this is again negative. So first we will solve this one and then solve this one into shape, and from this shape we have this values, and for inverse value for negative we have this negative value. The slope has been shifted or reversed. So from sketch the graph this indicating the coordinate of any point of intersecting with the coordinate axis. So this has to be solved. Question number 15. Question number 15, we have to solve this one. So let this is equal to this, and from here we have two x values, coordinates is this. So this is condition -5 to 1/4, where this would be negative or less than 0. So this is again less than and equals conditions. For part B, we have to formulate into this shape. So we have solved it, open it, expand it, and then equate it, and equate it to get this value A and B by equating the coefficients, and by placing it this, after getting this, placed at its appropriate positions, and for this we have this. So this is the minimum point at -4 and -25. This value will give a minimum point. This is the minimum coordinate of this quadratics. From this value we have this, so this would be the reverse. So on x-axis we have the same, on y-axis we have shifted, so this value would be positive. Y is shifted, x is remains same, x is remains, this is x, this is value of y, this will shift. So this is the maximum point. So from this sketch the graph. So we have this was the minimum value for minimum value, and for this was the maximum value. So we have plotted this maximum value and we have plotted this minimum value. this was the this was all from the examination parts. We have made some mistakes here, so I have informed everything. So this is less than 14, so this should be this between these two conditions. So because this is a curve like this, so here we have 2 and 14. So this is important. Remember, I will rectify this in this part. So good luck